Sometimes the winter season can make people feel housebound, as well as physically and mentally sluggish. But this winter season, not only full of the exciting Olympics, is also full of absolutely amazing developments that show just how determined and forward-thinking the human race continues to be in spite of adversity. Let's start in China. A beam of light weaker than the bulb inside your refrigerator has just delivered internet speed data from a satellite more than 20 times farther away than the International Space Station. The 2-watt laser, fired from geostationary orbit 36,000 kilometers above Earth, reached a ground telescope in southwestern China at 1 gigabit per second. Researchers affiliated with Peking University and the Chinese Academy of Sciences designed the experiment to solve a problem that has limited optical communications for decades, holding a signal together through the planet's churning atmosphere. The demonstration arrives at a moment when low Earth orbit has become a crowded highway. Thousands of satellites operated by companies including SpaceX being internet down from just a few hundred kilometers up, their constellations designed to minimize the delay that plagues real-time applications. This image shows geostationary satellites orbit the Earth at 36,000 kilometers, while the emerging breed of low and medium Earth orbiting satellites, LEOs and MEOs, orbit the Earth at heights ranging from 500 kilometers to 10,500 kilometers. Credit goes to Don Clark. The Chinese approach inverts current logic entirely, not just thinking outside of the box, but flipping the box and standing on it. A single spacecraft parked in geostationary orbit used a laser to achieve speeds the research team describes as 5 times faster than Starlink's typical user length. My brother Rupert pointed out that the 5 times faster claim from the article is a bit misleading. To quote him, there are 2 ways to think about this: the delay, latency, and the quantity, the throughput. The same way that you can ship a small item faster by airplane, low latency, but a lot more items by boat a bit slower, high throughput. The Chinese system has more latency, but more throughput. It has to have more latency. It is longer, and it's the speed of light either way. But they can pack a lot more information into the signal. So if you were communicating by voice or playing a video game, you would notice the lag. But if you were downloading a movie, it would finish downloading faster. Most people think of the lag when we say faster. Being able to focus a 2-watt laser through the atmosphere from that distance is absolutely a tremendous feat. Thanks, Ruby, for the clarification. The best part, the achievement is startling not merely because of the data rate, but the wattage. Conventional radio transmitters on geostationary communication satellites often consume hundreds of watts to send signals over similar distances. This laser system operated at 2 watts, roughly equivalent to an LED nightlight, yet maintained signal integrity across a path length that historically defeated optical attempts at high bandwidth. That is just a huge wow. Next, we head to Japan. Thinking of all the satellites and other space junk, the pollution caused by space debris, particularly aluminum particles, is a real issue. When satellites re-enter Earth's atmosphere, they burn up and release alumina particles, which can remain in the upper atmosphere for years. Developed by researchers from Kyoto University in collaboration with Sumitomo Forestry, the LignoSat project expects to launch the world's first wooden satellite later this year, exploring the potential of biodegradable materials to replace the metals traditionally used in satellite construction. Using wood in satellite construction is a revolutionary idea, but it is not as far-fetched as it might seem. Wood samples tested on the International Space Station were exposed to space conditions for nearly a year and showed little to no signs of degradation. Due to the lack of oxygen and living organisms in space, the wood did not decompose like it would on Earth. This is the final design used 10-centimeter long Hinoki magnolia wood panels assembled with a Japanese wood joinery method. Of course, I also had to check out the Sumitomo Forestry Company for sustainability. They have a very progressive approach to all aspects with a rate of recycling of 99.1% at their plants in Japan and an impressive dedication to decarbonization. But now let's head to Russia to a headline right out of science fiction. Here's the headline. Russian scientists build plasma engine that could reach Mars in 30 days, making Starship look outdated. I'll say. The coming decades of space exploration hinge on a single stubborn number, the 225 million kilometers between Earth and Mars. Chemical rockets, the workhorses of every space program to date, take roughly 8 months to cover that distance. Russian researchers now claim they can shorten the journey to 30 days using an engine that turns hydrogen into a high-speed plasma beam. This picture is by Master Sergeant Andrew Mosley. The propulsion system developed by State Nuclear Corporation Rosatom's Troitsk Institute near Moscow is currently undergoing ground trials inside a 14-meter vacuum chamber designed to replicate deep space conditions. If the technology performs as its creators project, it would not only shrink interplanetary travel time, but also fundamentally alter mission planning, spacecraft design, and the strategic calculus of governments competing for influence beyond low Earth orbit. The stakes extend beyond speed. A faster transit means crews spend less time exposed to cosmic radiation and microgravity, two of the most intractable health risks in human spaceflight. It also opens the door to routine cargo deliveries and eventually a sustainable human presence on another world. But the engine's dependence on an onboard nuclear reactor and its unusually low thrust raise questions about whether laboratory results can translate into a flight-ready system within this decade. Konstantin Guterov, the project's scientific advisor, said the prototype operates in pulsed periodic mode at approximately 300 kilowatts. Guterov added that earlier work had justified an engine life of more than 2,400 hours, which he described as sufficient for a transportation operation to Mars. The current testing phase aims to demonstrate the prototype's performance in that pulsed mode. This is an image of the magnetoplasma accelerator as it pushes hydrogen particles to 100 kilometers using electromagnetic fields. Credit goes to Sergei Lanchikov. Igor Biryluin, a junior researcher at the Troitsk Institute, outlined the basic mechanism. He said the engine relies on two electrodes. Charged particles pass between them while high voltage is applied, creating a magnetic field that pushes the particles out. The plasma thus receives directional motion and produces thrust. Biryluin also noted that the engine does not require extreme plasma heating, which limits wear on components and allows electrical energy to be converted almost entirely into motion. The projected thrust is about 6 newtons, which Biryluin described as the maximum among projects currently under development. With such characteristics, he explained, an interplanetary ship would need a reserve of time for acceleration and braking, meaning the flight would consist largely of smooth acceleration followed by deceleration. So why a hydrogen and nuclear reactor go together? The engine is not designed to lift spacecraft from Earth's surface. Launch vehicles with conventional chemical propulsion would deliver the vehicle to low Earth orbit, after which the plasma system would activate for interplanetary cruising. An onboard nuclear reactor provides the sustained electrical power required to maintain the electromagnetic field and accelerate particles. The working fluid is hydrogen. The rest of this news release does read even more like science fiction, but there are plans for a flight-ready prototype by 2030. So, Star Trek fans may be right. The futuristic show was just revealing the future.